Hey seniors, Mr. Hudson's actually going to be teaching you again here in just a few moments. In fact, he'll be teaching you all next week as well. But I wanted to just let you know that I'll probably at the end, the last day or two, I'll give a final farewell, so it's not just like I don't talk to you anymore the rest of the year. I did want to give you a real quick update on Mrs. Miller. Some of you may already know or have heard, but she went a week and a half ago to the cancer doctor again, and she actually got a good report, or an encouraging report. In fact, the last 2 times she went to her cancer doctor, she's had encouraging reports. So that is good to hear. Make sure you keep praying. God's already done several miracles. We thank Him and praise Him for that. Keep praying for more miracles and for healing. Back in January and February, there really wasn't a whole lot of good news to share with you many of the days and weeks as they dragged on. And so we're thankful for the good, encouraging reports lately. Again, keep praying for Mrs. Miller. So Mr. Hudson's going to come up now, and he's actually jumping ahead to chapter 8. We're kind of just jumping around to a few topics that we think maybe these topics will help you out. If you go on to a college class, we at least want you to have seen some of these things before, and it won't be your very first time in the college class here. So again, I'll check in with you again before the whole school year's over. You keep up with your work, keep doing a good job, and keep working strong right up to the very end, okay?
Alright, hello 12th graders. As Ms. Conch said, I will be teaching basically for maybe the rest of this, for at least the next couple of weeks for you guys, so get used to seeing this face here. You guys should be in, this is a pre-calculus video, so you guys should all be prepared with your pre-calculus books. We'll be on lesson 8.1 here. We'll be going over the first part there. I know last time we were at 7.1, but again, we're just going to be jumping all over the place here. So we'll be going through this whole chapter though. Alright? So please turn to chapter 8.1. Now this should be a familiar chapter. This chapter is actually an introduction to the rest of the the rest of the class, rest of the week here. We'll have the future lessons here, talk about matrices and such. But here though, we're just going to going over the substitution and elimination basically, which you guys should be familiar with algebra. Alright? So I could get started first and just jumping straight into the examples here. Just want to give you guys some quick reminders about maybe some terms and such that you guys have gone over, might have forgotten, might not be familiar with. Alright? So you guys just look on page 392 here with me then. That page here, they first talk about linear and non-linear equations. Do you remember a linear equation is just an equation that if you graphed it, it would just be a straight line. While the non-linears would be graphs such like a parabola or a curved line or like exponential graphs and such. Alright? And the other set of terms here that they give us here, I won't bother writing them down, is consistent and inconsistent. Just remember that a consistent system of equations, which involves more than one equation, a consistent one would involve there actually being an answer, while an inconsistent system of equations would just be no answer. Alright? Consistent, the answer. Inconsistent, no answer. Alright? So with that little bit of review there done, let's head on straight to example 1 here. Alright? So the book says use a substitution to solve the system, and then they give us 2 equations here. 6x minus 5y, which equals negative 43. Then 7x plus 2y, which is equal to negative 11. Now this should be familiar with you guys, since you guys have gone over it with algebra. So use substitution to solve for this. You guys should already have a bit of a head start and know what to do here. They say use substitution, so we can't just straight up say, all right, we can substitute this and substitute this in here. We're going to have to change an equation so that we can't substitute. And I'll just follow what the book does here. As the book says, let's aim for this 2y here, substitute that. Just because it has the smallest coefficient here, so then that'd be the easiest to work with. So if we're going to make this whole equation here to be y equals something, how are we going to do that? Well, we have 7x plus 2y equals negative 11. Write that down here. Well, first of all, we want to isolate the y here, so anything that's not part of the y set there, we subtract it and bring it to the other side. So that leaves us with 2y equals, I'll have the x here first. I know we have negative 11 minus 7x, but I'll write down negative 7x minus 11. And then we can divide by 2 here. Divide by 2 here. Y. Then, so here we have y would be equal to a total of 7x minus 11 all over 2. So now with this here, alright, again, I'll ignore that I circled that. That is not the answer for y. But here we're not going to substitute this here in. We can't substitute it into this equation here because that is, of course, the same equation we've got. So we are going to substitute it in to here. So we have y equals this. So we can substitute in 6x minus 5. Then we substitute in the y. The y would be everything inside the parentheses where y is. So we have negative 7x minus 11 all over 2. And then it equals negative 43 equals negative 43. And I barely left myself enough room again. Alright? Now the book takes a step here that they don't explicitly show, but what they did was basically multiply the whole equation there by 2. They multiplied this whole side by 2, and they multiplied this whole side here by 2. Times 2, times 2. And they did that there because we want to get rid of this 2 in the denominator here just to make it easy. So when they multiplied the whole thing by 2, they did 2 times 6x is 12x minus 2 times 5 times this, so the 2 and the 2 there cancel, so we get 5 times negative 7x minus 11 equals now 2 times negative 43, which is negative 86. So the book did here, you guys could follow along if you're following along there, they just multiplied the whole thing by 2, so they multiplied this here by 2, this one by 2, but this one here, the 2 then cancels here, so we get rid of the 2 in the denominator. Make sure you guys get that. So then, distributing these here, we're just basically solving this algebraically like you guys have done hundreds of times before in algebra. 12x plus, because we have a negative 5 times the negative 7x, 35x plus negative 5 times negative 11, 55, equals negative 86. Add the like terms together, so we have 47x plus 55 equals negative 86. Subtract negative 55 from both sides. So then we can isolate the x. 47x equals, now here, you guys have calculators, so you can do it on or just do it here in your head or actually on paper. But we have negative 86 minus 55. That there is going to be a negative 141. Okay, isolate our x, divide by 47. X equals negative 141 over divided by 47. That's going to be a negative since we have a negative divided by a positive. Then this here, again, it could be a bit confusing to see it be like, do that in your head or do that on your paper here. You guys could use your calculators if you want. But again, I'll just write down the answer here that they have. They give us negative 3. 47 goes into 141 3 times. So this here is our x. Now I know this is all review here now, but please bear with me here still. So we have our x here. Is that the final answer? No, we still need to solve for our y here. So, well, you look at that. We already have a y equation here. We can just insert our x into here and solve for y. So we have y equals negative 7 times negative 3 minus 11 all over 2. That would be the same as, we have 2 negatives there, but that makes them both positive. You guys do remember that the negatives cancel, you could say. So we have 7 times 3 is 21 minus 11 over 2. That there would be 10 over 2. So that would be 5. So that means we get y equals 5. Now one final step here. Do we leave our answer as this? Now whenever we're doing these sets of equations or system of equations here, we want to write the answers as, if we do get an answer like this, a unique answer, we want to have an ordered pair solution. So we do the parentheses, -3 for the x place, 5 for the y's place. Now this here is our final answer. All right? I know I'm always a bit all over the board here, but this should be what you got if you followed along with me on your own paper, and you guys should, hopefully you guys understand this. Please call me or Mrs. Cummins if you don't, or rewatch the video. But this here should be a bit of review, even though none of you guys should just be skipping this or zoning out or reading a book on the side while listening to this in the background. So that there gave us a solution there. But now they asked us to do example 2 here, and they actually give us the exact same equation, just that instead of solving with substitution, they said, oh yeah, use the addition method. And I know the book says addition method, but that is just the elimination method that Saxon had in your past algebra books. Bob Jones, Saxon, the other different books, they'll have like kind of different terms and maybe names for different methods. But when they say the addition method, all that they mean is elimination, all right? So that instead of using substitution, like substituting a y, we just want you guys to somehow cancel out either an x or a y, all right? So here we say use elimination. What do you think would be the best place? You guys should be familiar with these, so where would be the best? I'd personally say let's get rid of the y's, because they already give us a minus and a positive, so all you have to do is multiply by 2 positive numbers to just cancel them out. So let's multiply this whole equation here by 2. Let's multiply this whole equation here by 5. That would be the easiest way to get the coefficients on both of those to line up, so then we can cancel them out. So this top equation here becomes 12x minus 10y equals negative still, because we have a positive 2 times a negative number. That would be negative 86. So now here we have 7 times 5 by 5. That is a 35x plus a 10y equals negative 11 times a positive 5 and negative 55. So now we can kind of add those two equations together. We have a 12x plus a 35x. That is going to be a 47x. These 10y's here cancel because we have a negative 10y and a positive 10y. Then that will be equal to negative 86 plus a negative 55, or negative 86 minus 55. Either wording works. That there will then give us negative 141. And doesn't this kind of look a bit familiar to the last equation here, where we solved for x? We divide this side by 47, divide this side by 47. Those cancel. We have an x equals, you remember what we had last time? That there would just be a negative 3. And now, with this negative 3 x here, now we can solve for what y is. So we can substitute the negative 3 all the way up in one of these two equations here. And the book chooses one of them. It doesn't really matter which one we actually use to solve for y, but let's use the one that the book uses still, the top one there. They say we have 6 times x, which is negative 3, minus 5y equals negative 43. So 6 times 3 is negative 18, minus 5y equals negative 43. Remember, we always want to isolate the y here to solve for y, so we can add the 18 on this side here. Negative 5y equals negative 43 plus 18. That would be a negative there. So then that there would be 25. Divide by the negative 5 because we want to isolate the y. So we end up getting y equals positive 5. But now again, we don't want to leave the answer like this. We want the answer to be an ordered pair, negative 3, 5. And if you guys should see here, that's the same answer as we got in the last equation, the last example. This is probably refreshing, all you guys probably know this, but let me say it still for your guys' benefit. Doesn't matter, if we're given a system of equations that are the exact same, here we have the system of equations here, then both of them are the same. It doesn't matter if you use elimination or substitution. You're still going to get the same answer either way. So if the book doesn't specifically tell you to use substitution or elimination, you can use either one that you'll like better. Because in the end, you're going to get the same answer. All right? I say that a lot. All right. So sorry about that. I'll try to choose new words to say. But now let's turn to the next page here, to example 3. We're going to end on example 4. So after example 4, we've done this lesson, so please bear with me still here. This review may be easy for some of you, it may be something completely brand new that you guys have forgotten over the past years. But please bear with me still and listen to this, because going over all of this now will help you in the next few lessons here as we go over more advanced topics that I honestly find to be pretty fun. So example 3, they say solve the following system of equations. 3x minus 4y equals -8, and 6x minus 8y equals a positive 12. All right. Now the book doesn't give us an actual system, a way to solve it. They don't ask us to use substitution. They don't ask us to use elimination. So honestly, we could choose either way. Like the book does it one way there, and honestly, I tell you, let's just do the book's way, because the book seems to be choosing the easiest ways to do this. Let's use elimination, all right? And we could choose. Maybe, you know what, let's not do what the book says. Let's eliminate the x's this time. We eliminated y's, the first example, second example there. Let's eliminate the x's. So we have 3x and 6x. Let's multiply this whole top part by a -2. So in the end, we get a -6x plus, oh well, it's actually the same thing, 8y equals a positive 16. So then we have our second equation, which we leave there. 6x minus 8y equals 12. We add those together. -6x plus 6x, that's 0. Plus 8y minus 8y, that's 0. Then we have 16 plus 12, that'll be 28. So we end up getting an 8 equals 28. Now, is that a real answer there? Is that an answer that we could say that's a true statement there? Yep, 0 equals 28. Totally positive, yep. No, it's not. This here would be considered as a false statement. You should remember earlier I had talked about having like an inconsistent system of equations. This here would be considered inconsistent. All right? This here has no solutions at all, because 0 equals 28 is false. They didn't give us any x equals. They don't give us any y equals. This is a false statement, so it would be inconsistent. There is no solution. So if you get something like this in your homework, then you can just write down, after you solve it and end up getting some false statement, just write down there's no solution. Or if it asks, you can write down that it's inconsistent and such. Oh, right. So this would have no solution, so it would be either no solution, or you could also, for some shorthand, just do a 0 with a slash through it, and that may stand for an empty set, which basically means there's nothing inside of it. There's nothing. Actually, the book also calls it a null set, so I just find that pretty cool there. Because we also go over that in the more advanced maths, such as linear algebra or abstract algebra. This here is getting some stuff that will be with you guys for years if you continue following the math road. I should bring in my old math books from college just so you guys look at those. All right, but let's do example 4 now here, and then we can be done, and I'll give you guys the homework. Here. So let's look at example 4. They say solve the following system of equations, and they give us 4x plus 6y equals 12. And then they give us y equals -2/3 x plus 2. All right, now they don't tell us to use elimination or substitution, but what do you think we should use here to solve for this system of equations? I'm kind of feeling like we should use substitution, but I'm not sure why exactly I'm thinking we should use substitution. Well, yeah, let's use substitution here. So we have, we'll just substitute in the y from here into here. So let's use another different color. So we have 4x plus 6 times negative 2/3 x plus 2, and all that will be equal to 12. So now let's just solve for x, all right? So first of all, let's distribute everything. So we have 4x plus, then we have, here we had kind of like a little 6 times negative 2/3 x. So this would then be the same as 6 over 1 times negative 2 over 3. So if you've done in your head here, I just want to write on the side here for your guys' benefit. Just cancel the 3 and the 6, we get a 2 times a negative 2x. So that means we'd have a, not a plus, but a minus 4x. Then we have 6 times 2 plus 12 equals 12. Well, first of all, these here cancel each other. But let's subtract the 12 here. So that leaves us with 4x minus 4x equals 12 times 12. That's 0 equals 0. All right, now 0 equal to 0. Is that a true statement? Yes. Yes, it is. 0 is equal to 0, so this is a true statement. All right? You know, like on the previous example, we had said that 0 does not equal 28, so that would be a false statement. That would then be inconsistent. Here is a true statement, so this would still be considered consistent. But also, again, as review and such, that some might have forgotten, some of you may not know, but I'll write down here. We could have 3 different kinds of systems of equations here, all right? This one here would be considered, it's a true statement, this would be considered to be a dependent system of equations, all right? It doesn't have an exact x equals something or y equals something, but it does have a true statement when you solve for it. So that means that it has an infinite amount of answers. You could say that an infinite amount of solutions. So we can put down infinite solutions. There's no opposite of an empty set that we could use here, symbol. So you just write down something like infinite solutions here. Such, we'd accept that as an answer here. But like I said here, there are 3 different kinds of system of equations here. I keep on saying here a lot too. We have those that we consider consistent, those that do have an answer, and then those that are considered inconsistent, those that do not have an answer. So these have solutions, these have no solutions. Whenever we try to solve an inconsistent equation, we're always going to get something like 2 equals 3, 0 equals 28. Those are all false, so those be inconsistent. But now here, like we just solved here, now we got a dependent system of equations. We're going to have an independent. Hope you guys could read that there through the camera. Independent and then dependent. The difference between these, though, both of them have answers. It's just that dependent systems of equations, they have infinite solutions. They are always going to have something like 2 equals 2, 0 equals 0. All those are true, but they don't give us an actual x equals or y equals. So it has infinite solutions. Infinite solutions. Well, independent equations, like the first 2 examples we did, those had unique solutions. They only had one solution, one x, one y. All right? And those are always end up having like an x equals y equals something. All right? So that there would be basically what the whole first part of this lesson is. We will go into a bit more advanced systems of equations in the next lesson here, the next second part. But for right now, I'll just give you guys the homework here. And I'll write it down here, but do remember, not remember, I'll tell you guys this. This next homework here, do not turn in with your packet, all right? This lesson here, we're going to do the first part today on Thursday, and then for next week on Monday, you guys will be finishing up this lesson. So do not turn this in with your packet, all right? Because it would probably be incomplete, all right? So the homework we have for you guys is page 397 on numbers 1 through 8, 11 through 14, all right? And we have 2 days to do this. So this is a homework for today and for Monday's homework. So don't turn this in with your packet. So do not turn in. So everything that should be turned in for the packet, that's just going to be a worksheet that from Got Money, not money, on Monday. It should be your Desmos worksheet. And then your lesson 7.1 homework. Those should be the only things I see turned in. The worksheet and the one homework that we had for the 2 days that we've gone over on Tuesday and Wednesday.
The worksheet's actually 4 different graphs they're supposed to send me.
Oh, so your worksheet here should be 4 graphs.
Or they could have texted them to me as well.
4 graphs. So again, you can either turn those into the packet themselves or text it to Mrs. Cummins. Either way works, just make sure you get it in by Monday. All right, those are the only notes I have here. It's a Thursday, so there should be no video tomorrow. Well, there is no video tomorrow, but please do make sure that you have everything done so that you don't need to watch something tomorrow then. But I hope you all have a good day. It's good to hear about Mrs. Miller doing well and such. Please also pray for Annika and Ava from 9th and 7th grade as their grandparent has passed away, so please pray for them. I don't really have any other announcements here, so I hope you all do well with this homework here now.